Hello, my name's Richard. You want to weld today? Okay, let's get started. First thing you ought to do is get some safety glasses. You'll need them for any job you do in the lab. These will do. Follow me out to the metal shop. Remember, safety first. A clean shop is a safe shop. I would like to introduce to you the materials we'll be working with in the metal shop. First and foremost is mild steel, and it has the property of being able to rust. And rust is just iron oxide, and it usually forms on the surface. If given enough time, this whole thing will turn into rust and lose its structural properties. Another material we'll be working with is aluminum. Aluminum is a material that doesn't rust, so it's great for use in humid environments. Another material you could use is galvanized steel. Galvanized steel has all the properties of mild steel, but it has a zinc coating on it to prevent it from rusting. One drawback to it is that you cannot weld on it or apply heat to it in any way. Once you apply heat to it, the zinc begins to oxidize and burn, and it will off-gas. And if you breathe that in, it will make you very sick. We have stainless steel. This has all of the properties of mild steel with the benefit of being able to be welded using a specific process called TIG welding. Welcome to the tool room. This is where you can find all the hand tools for woodworking and metalworking and any other process that we use in the sculpture lab. So what we'll need to get started is a scribe. You can find that here. It's got a pointy end to it and a round end on the other side. We'll also need a center punch. A center punch is a lot like a scribe, but it's thicker. And it's got a blunt end where we'll be hammering on that end. We'll also need measuring tools, such as a set square. This is a very handy tool because it gives you a 90-degree angle here and a 45 here. It's adjustable, so you can measure any distance with respect to the edge of your material. A simple way to mark things out, say if I wanted to make this piece a rectangle with parallel sides. I'll be using this edge for my reference point. So I'll set my set square to 2.5. I'll put my set square against the edge here, flat against my edge, and now I can mark a perpendicular line with my scribe. Before we use the foot shear, we need to make sure that our material is safe to cut on this tool. This tool can cut 16 gauge, 18 gauge, and 20 gauge materials. Any smaller, it will bind up into the machine. Any larger, you're bound to damage the blades. It's a handy thing to have, but we only have about 2 of these in the lab, so you need to ask me where the gauge finder is, and I'll show it to you. This looks to be about 18 gauge, so I'll verify it by slotting it in to the tool to determine what size it is. So when you go to line up your material, you'll want to look down at the blade and line up the mark that we just made with our scribe. So you'll line up your mark with that bottom blade. So I have it about where I wanted it. So now, you'll have to brace yourself somewhat and stomp on this lever to get it to cut. So that's a nice clean cut right there. A hand file only cuts in a forward direction. It does not cut in the reverse. So every time you drag it across a material in reverse, it just simply dulls your hand file. So I'm going to tidy up that edge with this hand file, and it'll take seconds. So you don't want to press very hard getting started. You just want to slide it easily across the edge, going along the edge if you can. So I'm planning to drill a hole in this corner here. So before I do that, I want to measure out where that hole is going to be, and then I'm going to have to set that mark with a center punch before I go and drill the hole. I'll use my set square, and I'll drill the hole about 3/4 of an inch relative to the edge of the material. And I'll make a mark vertically and horizontally. You should be able to see a cross here. And right where they intersect, I'm going to place a mark with my center punch. The reason why you would use an anvil as opposed to a wooden workbench is because when you hit a workbench, there's a lot of reverberation. You hit an anvil, and it's a dull thud. So I'm just going to line up my center punch in the intersection of my marks and hit it once, and that's all you need. Before we use our drill press, we'll need to go grab a drill bit. Follow me and I'll show you where they are. We're inside the wood lab right now, but this is where we keep our drill bit case. These top drawers have the drill bits that you'll need for drilling into metal. You can also drill into wood or plastics or any other material that we work with in here besides concrete or stone or something like that. Let's get started by plugging in our drill press. Grab a heavy extension cable, something that has all of the plug-ins attached. Follow me. Come closer. So, what we're going to need to do is attach our drill bit into the chuck. The chuck has 3 teeth that retract and converge depending on how you spin the collet. So we're going to slide our drill bit into the chuck, and it's going to clamp down on the smooth portion of our drill bit. You want to make sure it's hand tight. Then grab your chuck key, which looks like this. This is a bevel gear, and this is a registration pin. There's a hole stationed on 3 sides of our chuck. 1, 2, 3. That registration pin slides into that hole and interlocks with that gear strip on the collet. So now we're going to rotate it on each side. It helps to kind of brace the chuck key to keep it from slipping. And we're going to go all 3 sides to make sure that that drill bit is secure. Always put the chuck key back where you found it. We have 2 magnets right here that keep it in place. Almost every drill press you'll encounter in your professional life will be set up just like this one. It is a belt-driven system. This is a very nice option, but it has speed recommendations here on this chart. So, over here, we have standard increments and metric increments. On this side, these are your drill bit sizes. So we have something that's around 1/4 inch. And come all the way over here, you'll see the RPM recommendation is 1570 RPM. And the belt locations are indicated with B2 1W. The chart up here will explain the location of the belts. So B2 1W. So now I'm going to set my drill bit in place. I like to rotate the drill bit backwards to center the metal, and I pin it down with the drill bit. You'll see I have an in-stop set to limit the travel of the drill bit. So I'm going to loosen this just a tiny bit because I want to drill into the metal and into my wood, but not into my platform. So I've set a limit of about 1/8 of an inch. It's important to have safety glasses on for this procedure, as well as keeping your hair tied back to prevent it from getting entangled by the equipment. We have a lot of options here. We have vice grips of different varieties. We also have C-clamps, which are very simple to operate. So we'll find a good place to place our clamps to hold our material in place so it doesn't move on us while we're drilling through. Let's put a final adjustment on our C-clamp to make sure that this doesn't move on us while we're drilling. So now we're ready to make our hole. Simple as that. So before we weld, we're going to need some jackets, like this one that I'm wearing right now, and welding hoods, so that way we can protect our vision. Over here, we have cabinets, some filled with leather jackets. We have the green cotton jackets, like what I'm wearing now. Welding gloves are in this box below, so we'll need a pair of those. Additional welding jackets. For those of us who have open-toed shoes or exposed ankles, we have these spats here. And they're usually nested like that. And they just clip right on. So that'll protect you from any sparks that could potentially go down your shoe. And last but not least, we have some welding hoods here. So yeah, let's grab some safety equipment and I'll meet you outside in the welding lab. So let's set up our equipment. We're going to attach the ground clamp. This is the ground clamp. We can attach it directly to our work table. So we want to make sure it's got good contact. We have our torch handle, and you're going to carefully unwind, and we're just going to set it on our work surface here. We're going to connect an air hose to our piece of equipment on the back side. So we're going to slide the collar back, press in, and release. Let's go look at our regulator to make sure that the pressure is set appropriately. We're in the foundry right now, and on the entrance to the foundry we have our pressure regulator and the other end of our air hose. Here there's a lever. If it is running perpendicular to the pipe, that means it's turned off. If it's running parallel, that means it's turned on. So let's power up our machine. We're going to go ahead and connect the power. And make sure no one's going to trip over that. And on the front of our machine, we'll just turn the on switch and you'll start to see all these lights come on. So now we're ready to cut. We got our welding hood and we got our gloves. So I'm going to cut on the mark that I made with the soap stuff. So I'm going to steady the torch with both hands. I'm not going to touch the metal. I'm going to stay right above it. Hold it simple. So going back to shut down, we're just going to do everything in the reverse order. First things first, we're going to shut off the machine. Cut the power. Coil the leads around the machine loosely. Try not to put any kinks in them. Do the same with the ground clamp. We'll disconnect the air by sliding the collar in the reverse, releasing the pressure. Try to coil it up neatly and set it back where you found it. Now we'll do the same with the extension cable. And hang it up right back where you found it. And that's how you plasma cut. So, before we weld, I think it'd be great if we did a little bit of practicing. So, whenever I do any practice welds, I try to find some scrap metal. And as you can see, this material has been welded all over. So this is a great way to practice. It's to just grab something that isn't your project, that isn't something you're going to keep. You're just going to weld these pieces together just to make sure that we have all of our settings correct on our welder. So just like with the plasma cutter, we're going to have to detach all of our leads and carefully place them on the floor where we're not going to step on them. Now that we have our ground cable connected to our work surface, now I'm going to connect it to the power. It's got a 220 plug, and I'll plug it into an outlet that's located right behind the cold saw. With your gauge finder, let's measure the first thing we're going to weld, which is this plate. 1/8 of an inch. So let's set up our welder. First thing you're going to do is to access the main valve to your welding gas. Let's open up the bottle. You don't have to jam it open. You could just leave it loose like this. Just make sure it's open enough to make sure that we don't have a reduction in the flow of gas while we're welding. This is the regulator, so this will regulate the amount of gas that flows out of the bottle. Let's go to the inside of our machine by lifting these tabs. We access the internals, and you'll see a chart. And this is common on every MIG welding machine. They'll give you a chart which explains how to set it up for welding the type of steel that you have. So we know we're welding steel. We're using a solid wire, 75% CO2, 25% argon. And we're using 0.035 inches wire diameter, which I placed a note on the edge of the spool as a reminder. So then we go down the chart underneath 1/8 of an inch, which is, these are our material sizes here. And you see 3/40. Well, what does that number mean? So you go up here, it says to read settings. First number is voltage, second number is wire speed. Over here, we'll set it to 3. Make sure it sets in that notch securely, and then we'll set it to 40. Let's turn it on. Let's check the regulated pressure. I'm just going to click the button on the handle here to see where we're at. I'm at 25 CFH. With this extra wire hanging out, you can wind it back up onto the spool very simply by taking the tensioner loose here. So the tension's relieved. And now you can roll it back into the torch lead. Okay, so now that everything is set up and we're safe, let's start to weld. You're going to want your wire to be as close to the contact tip as you can. And when you go to weld, you're going to want to steady the torch, keep it perpendicular to your material, and you're going to want to be about 1/4 inch or less away from the surface. You don't want to make contact directly because it will cause the welding torch to stick, and it might be hard to pull away. So it physically welds itself to the metal if you stick it directly on. So don't do that. Before you weld, you want to announce something to somebody. If you have multiple people working in here, you could say welding, or you could say eyes, or sparky spark, anything you want. Just let somebody know before you strike an arc and potentially blind somebody. Welding. A tack weld is just a weld that is there temporarily. It holds up the work, but it's not structurally sound enough to be a permanent attachment point. I'll show you what that looks like. Welding. That's an example of a tack weld. Welding. That should hold. No, it's bigger. It's close to, it's a little over 5/16. So it could be a 1/2 inch, maybe. It's thick. So again, back to the chart. I'm gonna say let's set it to the settings for 3/8. So you come down here, you see voltage is 5 and wire speed is 55. 5, 55. Welding. Welding. Last thing I want to show is how to put away your welder. So this was the first thing that we did when we were setting up our welder. So it's also the first thing you do when you're shutting down the welder. The next thing I like to do is just set everything to 0 or 1. So I'm just going to click the handle until this ball drops. So now it's 0. With this extra wire here, we can save that by just rolling it back into the torch handle. So now that that's put away, there's no need to keep the welder on, so we'll shut it off and start to coil our leads. Don't forget to unplug the machine before you start moving it. And we'll just coil it up around the tank here. Just like that, nice and neat. And we'll put it back where we found it. So we have different varieties of angle grinding discs. So this is just an angle grinder disc. This is good for grinding down your welds to where they're smooth. We have the cutoff disc. This is great for cutting things off, as the name might suggest. We have flap wheels. Flap wheels are layers of sandpaper that are kind of laid like fish scales on the surface. That could leave a nice polish. And here we have our angle grinders. Now, if you wanted to change the angle grinding attachment, you can do so by pressing this button here, which will lock the wheel in place. So while holding that, you grab your spanner and you loosen the retaining nut. So the next thing you'll want to grab is some batteries, and we have a bank of batteries over here. There's some that are already charging, so I know they're good. So I'm just going to grab one off the charger, and it goes on the bottom side of the angle grinder. Goggles are preferred because this puts off a lot of debris. These tools are very loud, so you'll want to grab some hearing protection. We also have earplugs in the same cabinet that we have our goggles and our safety glasses. Whenever you're using any rotational equipment, such as the drill press, an angle grinder, or anything like that, you want to make sure you don't have any loose clothing. So making sure that your shirt's buttoned and roll up your sleeves. And you want to make sure that you don't keep any gloves on your hand because that can actually pull your hand into the angle grinder. Makes quick work. I'm going to grind that flush with the angle grinding disc. Before you make a tool change, pull the battery out by squeezing the two buttons on either side of the battery. Lock that in place, and you could rotate it loose just with your hands. And while still keeping my finger on that button on the top side, tighten it by hand.